Problem number 1. Consider the 3 flasks in the figure. Assume that the connecting tubes have no volume and the temperature is held constant. A. Calculate the partial pressure of each gas when all stopcocks are open. B. Calculate the total pressure when all stopcocks are open. The problem tells us that the temperature is going to remain constant. We can assume that the moles will also remain constant because helium, neon, and argon are all noble gases, and they're not going to react with each other when they mix. Since the temperature of our system and the moles is being held constant, we can use Boyle's law. Boyle's law is a principle that describes the relationship between the pressure and volume of a gas. According to Boyle's law, the pressure exerted by a gas held at a constant temperature varies inversely with the volume of the gas. So mathematically speaking, initial pressure times the initial volume will equal the final pressure times the final volume. Using Boyle's law for the information we're given about helium, helium's pressure is 200 torr when the stopcock is closed. Helium has a volume of 1 liter when this stopcock is closed. But once this stopcock is opened, the helium gas, the molecules of helium, will leave this flask and diffuse into the other 2 gases. So then the final volume of the helium spread out over the entire 3 flasks would then total the volumes of all 3 flasks. 1 plus 1 plus 2 is 4. So using Boyle's law, the initial pressure of helium is 200 torr. The initial volume is 1 liter. The final pressure is what we're trying to calculate, and the final volume of the helium is going to be 4 liters. So solving this for P2, which represents the pressure of helium, that would be 50 torr. Calculating the partial pressure of neon after the stopcock has been opened, again we're going to use Boyle's law. P1 times V1 equals P2 times V2. The initial pressure of the neon in the 1 liter flask is 410 torr. The volume of this flask is 1 liter. Once the stopcock is opened, the neon will escape or diffuse out of this flask and into the other 2. Plugging in the information given in the problem, 400 torr initial pressure, 1 liter initial volume equals the pressure that the final volume will be 4 liters. Solving for P2, the pressure of neon is going to equal 102.5 torr. Calculating the partial pressure of argon once all the stopcocks are opened, the argon is going to escape from its initial 2 liter volume flask and diffuse into the adjacent flasks. The initial pressure of the argon is 250 torr. The initial volume is 2 liters. The final pressure, we don't know. We're going to calculate that using Boyle's law. The final volume is 4 liters. Solving for P2, the pressure of the argon is 125 torr. So each of these pressures, the pressure of helium, 50 torr, pressure of neon, 102.5 torr, and the pressure of the argon, 125 torr, are all the partial pressures that each individual gas is exerting on the inside of the flasks. Now we need to calculate the total pressure. Using Dalton's law of partial pressures, the total pressure is going to equal the pressure of all the individual gases in the system. So the total pressure is going to equal the pressure of the helium plus the pressure of the neon plus the pressure of the argon. So using the values we just calculated, P total is going to equal 50 torr plus 102.5 torr plus 125 torr. Adding those 3 numbers up, the total pressure of the system after all 3 stopcocks are open will be 277.5 torr. That's the problem. Ask some questions.